ready?
Howdy. We're JMATA. I'm John.
Matt.
I'm Adam.
I'm Andy.
Okay, our objectives was to obviously build a Rubik's Cube solver. We tried a whole bunch of different ideas. We watched some videos on YouTube of different designs people have made, and then we found a website with a design we liked, so we tried building that.
This is our first design. Actually takes more time than this final design. We want to build Unix, so we look for internet for a long time. Then we finally found this kind, and we build by the follow the instructions we have. And the problem we have is the base is not strong enough. So when we make the whole robot run and this and cannot match the Rubik cube it's very well. So sometimes when we flip the Rubik cube, we got a little problem. So last Friday we meet one more time and finally we decide to change all the design to this one.
Alright, so like Andy was saying, we were encountering those issues. Mostly it became a time problem where we could solve, one little problem at a time, but we weren't making enough progress to meet our due date. So, like everyone else, we switched to the tilted twister, and at that point, that was like Tuesday, so we really didn't have time to do much else. And so we spent a little bit of time messing around with our own program, but that's you see right there.
Our preliminary program was pretty simple but yet complex. A lot of loops to it, just trying to get the turntable to move and our claw to hold on to the cube while the turntable was spinning. We also messed around with using the touch sensor to move the turntable. That worked, but not well enough to keep it in the design. And then we went to a different program.
So I wrote a randomizer. I figured since we can't solve a cube, maybe we can just put a fully solved cube in there and it'll make it completely random. So initially it showed that it could just go through all three axes of movement, and then using the random function then sets of different numbers and values, it goes through these 5 different options and basically it loops it through it there. And right at the beginning it even has an option not to randomize it as part of staying true to being random. And then this loop will run indefinitely until it lands within a number range that says it can stop.
Our final program, Jay helped us out figuring out how to move the 3 different axes, and so we figured out that the cube needed to be held by the claw, so we had to move the claw first, and then use the turntable to move the cube, and then it went through a whole bunch of process, and we added the light sensor just to see if we could. And if we had more time, we probably would have tried to see if we could get it to help solve the cube. Right now it's just going through the motions, basically.
Yeah, so after meeting last Friday and seeing that our original design wasn't working out very well, I decided to take this home and just follow the instructions online for the tilted twister. Brought it back on Monday and then programmed the sequence of turns, holds, and flips to get it to spin all 3 ways. And at the very end we had a little bit of time for the light sensor, so we just got it to swing in there and kind of scan it, but not really, and threw that in our final design just to show that we made a little bit of progress with it. So that's pretty much where we're at with our final design. So I guess we'll run it.
Kind of like Supernova 2 at the beginning of class for running into problems with low battery power, and then it wasn't turning properly. So
Yeah, this morning it wasn't working.
Jay very easily ran out and got the battery.
That one out of the.
Yeah, we're gonna try that one time. See how it goes.
So 8 out of 10 times.
Yeah.
Maybe you raise the back up a little bit.
Light sensor's working.
Just squeeze it inside and try it.
Strips out the block.
I think the problem is the carriage is not straight.
Powerful.
Working early.
Okay, try one more time. Can you?
No.
Yeah, maybe. No. No. You want to see it one more time? Yep. Just
Run the randomizer. See if we can get it to hold it.
There we go.
okay.
Yeah. Yep.
Okay. Sound good.